Hi there, this is Ajay. Welcome to Step by Step Data Science tutorial. So today we are in part 13, image compression using k-means. In last video, we wrote all equations from scratch for k-means, and in this particular video, we will apply k-means and compress our image. So this is the dataset I have used from Andrew Ng Coursera, and it contains the image of a bird, and we will apply k-means and compress the image. So let me look at the shape of this image. So this image is 128 by 128 pixel with three RGB channel. Now let's visualize this image. Called plt dot time so bracket e. So here we can see this is my image of a bird, and we will apply k-means to compress this image. Okay. So if we look at my data set A, so it is in numbers from 200. So some has 100, 200. Now what we will do is we will pre-process this with uh, this array. So we will divide our A by 255 so that my all numbers are between 0 and 1, and I will reshape it to two dimension. 0 times A dot 0 times A dot 1 comma 3, and this will be my x. Reshape reshape sorry, type not reshape. Now if we look at my x, now all my array is converted into 0 and 1, and this is a red channel RCB. If you look at shape dot shape, now it is in two-dimensional array. We did multiplication of 128 by 128 pixel image. Okay, now what we will do is we will apply k-means for this image. So in last video we wrote all these equations of calculating in finding my closest centroid, computing centroid, and we even did a visualization, and we even randomly initiate our centroid. So if you have any questions regarding, if you have any confusion about this code, you can view my part 12 video, which is given in description below. So today we will write the last function for running k-means. So be myself comma x comma my centroid. So my index will be self dot. So I am writing the function so that I can get my centroid and index at once. So I'm merging my function into one. So this is my index, and I will even need to write iteration, how many iteration you want to run your k-means. So for I in range of number of iteration, so I want my centroid will be equals to self dot the centroid and my index will be equals to this is my centroid. Okay, now I will return my centroids and index. So let me check if this is working fine or not. So I will create an object for my k-means, and I will pass my number of cluster as 16. So 16 is the number of cluster. That is the way we group the image so that the final image will be a compressed image. So we will group on the basis of 16 different colors, and then we will do random initialization of our k-means. So this is the random initialization function that we wrote in last tutorial. So if you have any confusion, you can view my last tutorial. We'll pass x here. This will be my initial centroid, and then I will run my k-means, pass my x, comma, number of centroid, comma. So I will do 10 iteration, and let me store my result as accomplished centroid, comma, compressed index. So let's see if this is working. So I need to keep my object here. See if this is working or not. So here my number of cluster is so my k is equals to 16. I have 16 colors. Now what I will do is I will create a copy of my x variable, x dot copy, and I will run my key means from range from 1 to k plus 1, and my x compress will be equals to, so if my index of index that we got is equals to I dot variable to flatten my data, comma, all columns, this will be equals to my centroid, so which I have calculated to group my data. So this will be I minus 1 because I have started from I as 1. So let's run this. So here my k is 16. Okay, so let's keep k here. So this is successful. Now what we need to do is we need to again resize our compressed data, because my compressed data is in, if you look at the shape, it is in 2 dimensions. We need to convert this into pixel by pixel, like row and column in pixel. So let's again reshape this, not reshape this to this size. Okay, so this is my compressed portion. So if I look at my shape, dot shape, yeah, so it is in 3 dimensions. Now let's visualize my output. So I need to create a soft plot to visualize both my original and compressed image. ld.soft plots bracket 1 comma 2. So my ax of 0 is equals to ld.im, so bracket this one x. Again need to resize this dot reshape it to original dimension. So this is my original, and this is my compressed image. From this, I am so reshape it to a 0. Let's check whether it's been recompressed or not. Yeah, it's working fine. Let's check a dot save. It's 128 by 28. This would work. Hmm. Do let's here. Let's check my save. It's not saved. Now let's pass this X over here. Oh, sorry, this needs to be here. This needs to be here. This is my image 1. This is my image 2. Okay. Pass this over here. Okay. So this is my original image and this is my compressed image. Now, so let's give a title. I range of 2. Title A. The first one is the original image and second one is my compressed image. Okay, so ax of I dot set underscore title. Okay, now we have title. So now I will be changing this to a function so that I can visualize my own data, and instead of writing this code again and again, I will create a function so that I can apply the same in my image. Okay, so let's create this as a function first. So let me create this as function def compressed image bk comma x comma k comma number of meter, and I will shift this bit here, apply the compression here, and then I will return my x dot compress. Okay, so my compressed should have x, then my 16 is my number of cluster and 10 is my number of iteration. This would give x, and then I need to reshape this again to my original image. Close, cancel this out, cancel this out, and then again I need to reshape this. Cancel this even out, this out, and even for my visualization I will create a function dot underscore image here as original comma compressed and then in here I will pass my x comma x underscore compressed. This is my x and this is my compressed. Give here semicolon. So yeah, this should work now. Let me restart and run this off. So this is my original figure and this has been compressed. So this is how we compress our image through k-means clustering. So what I did, I clustered on basis of 16. I took my cluster group as 16. I did 10 times number of iteration. I applied 10 and I compressed my x in a way that my index matches with my centroid, and then I did visualization. Now let's try to make to compress my own image. So this is my own image. I'll try to compress by using k-means. So if we look at the size of this image, shape of this image, so it's 140 by 140 pixel RCD channel. So what I will do, I will again apply my compression, pre-processing cost. So I will set a as my image, plus this image, apply pre-processing, and then I will call my this function here, and again my k will be, my k is 16, already it's defined in upper cell, and then I will again do the reshaping part. So this is my reshape part of the original image, okay, and then I will do visualization. Okay, right. So this is my original image. I have assigned my original image to a variable. I have reset it and then applied my compressed function. K is not defined, so k is equals to 16 and number of iteration is 10. So this is giving us an error. It's working around. I've restarted and again. So I have called my x underscore compress 2 times. So I will remove this. Maybe this was causing the issue. And then we say, now let me rerun this again because this was called 2 times. It will give an error. Definitely it will give an error. So it's working. It's working. So here this is my original image and now this is my compressed version. Okay, so this is how we apply k-means clustering to compress my images. Okay, hope you learned a lot from this video. Please like and subscribe my channel. Thank you so much.